Alright, now we're going to talk about radioactivity. It turns out that some atoms are unstable, and specifically it's the nucleus that is unstable, and it can spontaneously break down. And we say that the nucleus decays, and this process of decay emits radiation. So atoms that do this are said to be radioactive because they actively emit radiation, and the process is called radioactive decay. Now, there are three types of radiation that are emitted from radioactive decay, and we'll go over these three types and talk a little bit about radiation in general, and then later on we'll go into detail about the process by which the nucleus decays. So first, the three types of radiation. We call them alpha, beta, and gamma. And those are the first three letters of the Greek alphabet. Alpha, beta, and gamma. And they're commonly indicated by the letters. The Greek letter alpha looks like this, and beta looks like this, and gamma looks like this. Now, alpha radiation is a particle. And it's a positive particle, and specifically an alpha particle is a helium nucleus. So I'll draw this with two little protons and two neutrons. And that's what it is. It's a helium nucleus. So what happens is a larger nucleus breaks down, and one of these things comes flying out of it. In other words, two of the protons and two of the neutrons clumped together have broken off of a larger nucleus, and they go flying out. And it's called radiation because they come flying away from the original atom that's decaying. And these can do some damage. They can damage your skin, but they're easily stopped. So even just traveling through the air, the positive charge on these protons attracts some electrons, and it just becomes an ordinary helium atom. And so they're not as dangerous as the other types of radiation because they're easily stopped, and they don't stay moving real fast in this state for very long. Beta radiation is also a particle, and specifically it's a single electron, and it's no different from any other electron. All the electrons are the same. What has potential to do damage as radiation in this case is the fact that it's moving really fast, so it has a lot of energy, and it can penetrate and can damage living tissue. Once it's stopped, though, by whatever it runs into, it just becomes an electron in that material and is no longer doing any damage. So I'll just mention that this is a single electron, a beta particle. But specifically we call it radiation because it's emitted at high speed from radioactive decay. And then gamma radiation is a high energy light wave. Or if you're thinking of the light as a particle, you would say it's a high energy photon. Either way would be correct. And gamma rays are the most dangerous and the most potentially harmful. Gamma rays can penetrate most materials, and they can cause a lot of damage to living tissue. They don't easily penetrate very dense materials such as lead for great distances. But you would need some thick lead, not just like a little thin sheet, but say an inch or two or maybe more to shield against gamma radiation. But out of the three types of radiation, the gamma rays would be the most harmful.